Alright, so today we're going to be treating number basis, and what I have here before me is convert 0.11101112 to base 8 and base 16. First of all, we know that base 2 numbers are called binary, and that's why we normally talk about computer being digital. They are talking about system of number in 0 and 1, and this is the language computer understands. So notice that by base we mean that you have 1 and 2 bases, so you can never get to 2, but it ranges this way. So whenever I want to convert a number from god, where's my duster? Let me get my duster. So this base 2 number. So whenever I am to do base 2 number and they are telling me to convert a base 2 number to another base, I need to check what base are they asking me to convert. Today's class is all about binary to octal and base 16. So I'll ask myself, when is 2 ever 8? I know that 2 is 8 when I have 2 raised to power 3. And this is the sentence I'm saying 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. And this is the sentence I'm saying 2 raised to power 0. Sorry, 2 raised to power 1, 2 raised to power 2, and 2 raised to power, yes, and 2 raised to power 3. So notice it. So you see that this is when I have base, when I have 2 to 8. So you see that it gives me 3 places. So whenever I want to convert any number from base 2 to base 8, I must make sure that what I'm doing, we have three places, or you say 3 bases. So check it, and you know that base 8 numbers are numbers that ranges from 0 to 7. So notice that 2 raised to power 3, what I have here, these 2. If I bring it down, let's check. Let me just analyze, see what I mean by that. At this position, see what I mean. If I have 2 raised to power 0, 2 raised to power 1, and 2 raised to power 3, we see that 2 raised to power 3 is 8. Yes, I know, it's 8. But let's do it this way. This is going to be 2. This is going to be 1. And if I have that, the next one, 0, 1, before this, raised to power 2, is going to give me 4. And that means that I'm going to have 1 plus 2 plus 4 is 7. So that is another reason why whenever we are treating base 2 to base 8, we make sure that what we have is in 3 places, since base 8 gives 2 raised to power 3. So that 2 raised to power 3, that is 2 in 3 places, is what we change to this. We change it to mean when I have 2, have 2, have 2. But now we're starting from the first power. The first power of anything is always 0. So we say 0, 1, and 2. So if I know this understanding, you need to have it. So if I know this, it simply means that when I say convert 1 to base 2, is the same thing as saying 2 raised to power 0, which is the same thing as saying 1. And you know that if it's 1, if I'm converting this 1 to base 2 and it's in base 8, let's say I'm converting this 1 this way and I'm trying to move it to base 2, what I'll do is say, remember that I will have 3 positions, this way, and this way. When it's 2 raised to power 0, when it's 2 raised to power 1, and when it's 2 raised to power 2. So I'll simply say 2 raised to power 0 is 1. So notice that 2 raised to power 1 is 2, and that is not 1. So I'll have 0 here, I'll have 0 here. 2 raised to power 2 is 4, and that is not 1. The only one that is 1 is this. Let's say I want to convert 2. This time in base 8. Let's say I want to convert 2 in base 8 to base 2 now. See what it simply means. I've gotten it. I know that base 2 to base 8 now is simply going to be when it's in 3 places like this. So I'll ask myself, to convert 2 is simply 2 raised to power 0 is 1. Yes. 2 raised to power 1 is 2. But 2 plus 1 gives me more than. So it simply means that this is supposed to be just 2. Then I have 0 here, I have 0 here. And remember, we can't write 2. We can't write 2 in base 2. So we simply indicate it with 1. So it's more like we're using 1 to show that it's there, 0 to show that it's not there. So converting 2 to base 2 is simply 0, 1, 0. Now what about 3 to base 2? 3 is simply going to be 2 raised to power 1 is 2. So I put 1. Anywhere that is active, I use 1 to represent it. It's not, if it's not going to be there, I use 0. So 2 raised to power 0 is 1. 2 raised to power 2 is more than 3, so 0. So this means 2 plus 1, which gives me 3. So this is how you place it in binary. What about 4? Let's say they ask me to find. So you always start, I think, if you're going to get confused, the best approach is simply to remember. Always start from 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and so on. But this time we are treating base 8. Assuming it's base 16, we'll now make room for 2 raised to power 3. You see that this is 2 times 2 times 2 times 2, which is 2 in 4 places, is 16. So we'll do like this. But since we are still in base 8, let's go like this. So if I have 4 now, I want to convert it to binary. I'll simply have 2 raised to power 0. 2 raised to power 0 is 1. Plus 2 raised to power 2. 2 raised to power 1 is 2. That is 3. But already I have 2 raised to power 2 gives 4. So I'll use 1 to show that it's on. Then every other thing here will be 0. Because if I put all these ones, it will be more than 4. So this shows 4. And for example, if I have something like this in binary, I just have 1 like this, and I want to convert to base 8, I'll just use 0 to complete it so that it will be in 3 places. So as you get this understanding, as we progress, it will become, it will make more sense to you. So let's convert what we have here. Here we have 0.111011112. Starting with base 8, I'll simply bring it out. I have 0.111 base 2. So since I'm moving to base 8, I'll simply group this in 3s. So starting from this, I'll group it in 3s. So I noticed something. I think, let's say the best way to do this, to group it, is simply starting from the points from this side. So let's do it again. I'll have 3, then I have another 3. Now notice that there is 1 here. It's in base 2. I have 3. I have 3. So it's remaining. So I will just complete it with 0. I've completed it with 0. So what I need to now start doing is, the minute I do this now, I'll start using that same approach. So to convert this to base 8 now, I'll simply start using the approach of 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. And notice, if I come and do 2 raised to power 1 times 0, or this is the sentence saying it is not here, there's nothing here. There's nothing here, which I told you, whenever you see 0 for the binary side, know that it means off once you are talking about binary to octal. So that means that the only thing on here is 4. So let's move to this one. I see this is the sentence saying 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. Well, notice that this is 0, and anything times 0 is 0, so it's off. So that means the only one I'm considering is this 2. 2 raised to power 0, which is 1. And 2 raised to power 1, which is 2. So when you times this with this, it gives you 2. Times this with this, it gives you 1. So add it up, it gives you 3. Then let's come here. I see 1. I see 1. I see 1. This is something I'm saying 2 raised to power 0. 2 raised to power 1. 2 raised to power 2. So anything times 1, times 1, times 1 is that. So this is something I'm saying I have 1 plus 2 plus 4. So if you add it up, it gives you 7. So 7. So that means that, and notice that there is point here, point 0. So your point, you always carry it down. So point 0. So which means that everything I have here in binary is 0.734 in octal. Octal number system. That number system or number base, that base that ranges from 0 to 7. So this is how you go about it. Alright, let's try to convert this to hexadecimal. And doing that, okay. Let's be sure. I have 0.111011. Should be? Okay, let's work with this. Yes. Yes, okay. I was able to group it 1, 2. Okay, yes. So base 2. Base 2. So let's try to convert this to hexadecimal. Now for hexadecimal number system is the same thing as having base 16. So whenever I'm converting from binary to hexadecimal, I'll simply say how many places will you have 2 in order to get 16? Is 4 places, which is the same thing as saying doing 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3. So just look at it. If I look at this very well, I'll see that this is going to give me 2 raised to power 3, 8 plus 4, 12. Okay, so let's do it. This is the same thing as saying 8 plus 4 plus 2 plus 1. So 12, 13, 14, 15. And you know that hexadecimal number system has from 0 to 15. It can never get to 16. So when you are treating like base 10, that's why you always have 0 to 9. Once you have something that brings about 10, you say carry 1, drop 1. So that is the same approach you're using here. So if I'm using that same approach, it simply means that for converting from binary to hexadecimal, I will make room for 4 boxes. So that means that everything I have starting from this point, I will go and partition it in 4 places. So I will now have 1, 2, 3, 4. So if I notice this is in base 2, if I notice there is something that is supposed to be up to 4 that is not up to 4, I put 0 to complete it. So that means now we can go ahead and convert. So okay. So let's now, using the same mindset now, we'll come for each box. We say this is when 2 is raised to power 0, 2 is raised to power 1, 2 is raised to power 2, 2 is raised to power 3. Which means that when we have 0, it's off. And all these things, you separate it with plus, because whatever you get, you must plus. So you see that you now have 2 raised to power 0, 1. 1 times 0, 0. Now 2 raised to power 1 is 2 times 1, 2 plus 2 raised to power 2, 4 times 1, 4, plus 2 raised to power 3, 8. 8 times 1, 8. So add it up, you get 14. That is 9, 10, 11, 12, 13, 14. 14. So you just write it. So everything this side, everything here, everything about this side gives you 14. We'll write it. Now, the same thing I drew here, that's what I'm using here now. So this side is going to be, so I do this. This is the same thing as when 2 is raised to power 0. And everything here, for the fact that is 0 here, it means off. So 2 raised to power 0 here is 1. 1 times 0, 0. Plus 2 raised to power 1, 2. 2 raised to power 2 times 1, 4. And this side will be 2 raised to power 3, 8 plus times 1, 8. So do it. You have the same thing. So 14. Now you have points 0. So that means that you have 14 and you have 14. The mistake most students do is they want to come and start adding. You don't add. But remember that base 16 numbers are those numbers that has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The minute you get to 10, you start doing A for 10, B to represent, A to represent 10, B to represent 11, C to represent 12, D to represent 13, and E to represent 14. Then F to represent 15. If you check it, this is place 1, place 2, place 3, place 4, place 5, place 6, place 7, place 8, place 9, place 10, place 11, place base 12, 13, 14, 15, base 16. So this is how you check for the base. If you add 16 to it, it becomes more than base 16. So base 17. So this is base 16. You must stop at 15. So see that when I have 14 is E and I have E. So this is simply the same thing as saying 0 points E base 16. This is your final answer. This is your final answer. Alright. So with that said, I have questions, other questions that I want us to look at still under number basis. And I told you that number basis is a way of counting numbers, or you say is a type of numbers, a type of natural number system. Yes. So number system, natural number gives us what we call number basis, because natural number talks about counting numbers. So number basis is way of arranging numbers in bundles or counting numbers. So if I'm not using base 10, I can use any of the bases. So right here we have convert 88 to base 10 to a number in base 2. Then we also convert to a number in base 5, then to a number in octal, then to a hexadecimal. So let's start with the first one. This is 88 to base 10. So they want us to convert this 88 to base 10 first to base 2. So whenever I have a base 10 number, I always divide with what I'm asked to convert to. So this is 88 to base 10. So for the fact, anytime I have any number in base 10 and I want to convert it to any base, I will always simply bring out that number that I'm given, the one in base 10, and divide it by the base I'm taking it to. So assuming it's base 5, I'll divide by 5. But here I'm taking to base 2 first, I'll divide. 2 into 88 will give me 44. 2 into 44 will give me 22. 2 into 22 will give me 11. And notice that